Hey, pre-calc classes, today we're going to do day 2 on the assignment sheet. We're going to finish up with section P1 with some simplifying variable expressions and also go back and review our exponent rules. So first off, we've got an expression to evaluate with order of ops, and the first thing you want to do is put all the right numbers in the right place. So we're going to do that. And the 3 goes in for the x squared. And the negative 2 goes in for the y, adding z to the 4th, and everything goes over y, take away z to the 4th power. All right, now even though you got your calculators, we'd like to make sure we can see some partial steps here, as well as having you follow order of operations. The fraction bars mean that you basically got 2 parenthesis quantities to simplify separate of each other. So you've got to be sure you finish the top of that fraction before you finish the bottom. All right, now we hit order of ops in the top. We do the exponents first, so we're going to do the powers here and the powers here. And then we're also going to go in the bottom, and before we do that power, we've got to do the parenthesis. All right, so back to the top. We've got 2 times 3 squared, 2 times 9, times a negative 2. Negative 1 to the 4th power, be a positive 1. To the bottom, we're going to have 2 plus a positive 1, so we have a negative 1 to the 4th power. We come back to the top. We do the multiplying before we do the adding. So we've got 18 times a negative 2, negative 36, plus 1. The denominator finally simplifies. Negative 1 to the 4th power is 1, and we've got a negative 35. All right. Next up, we are going to do some variable expressions, again, keeping in mind your order of operations, even though there's no numbers to plug in here. All right, so we see no exponents. So the next thing in order of ops is we think about the parentheses, which also refers to grouping symbols. So in this particular case, we go to the innermost grouping symbols and perform those first. You do not work left to right as though you're reading a book. You've got to look at the grouping symbols and go to the innermost one first. All right, so that means we are going to simply be rewriting the 7 plus the 2, as well as the bracket where the 5x is. All right, here we're doing the distributing of negative 3 through. So minus 12x and a positive 3. Now you have your choice. You can either finish up simplifying inside that grouping symbol before you multiply, or you can distribute through. So I think I'm going to come back here and I'm going to finish up going back through that parenthesis. Again, don't do the 7 plus the 2. Finish up inside your parenthesis, negative 7x plus 3. And then finally, the multiplication has to come back, and it has to follow before you do the addition. So 7 plus negative 14x plus 6, and then finally you're done. Negative 14x plus 13. All right, now we're moving on to exponent rules, something that we've seen way back in freshman year, probably even before that. So they've got the collection of all the rules here, just to kind of talk about before we go into actual examples. Multiplying product of powers with like bases, the exponents add. Power to power, a power raised to a power, they multiply. If I have a product raised to a power, each factor in the product gets raised to that power. Same thing if now if I have a quotient of powers, same base, there I'm subtracting those powers. Good old 0 power, any number to the 0 power is equal to 1 except 0 to the 0 power. No value for that. Power of a quotient, both numerator and denominator get that power. And the negative power, we used to call it the move it and lose it rule. Your negative power is in the numerator, it goes to the denominator and loses the power. If your negative power is in the denominator, it moves to the numerator and loses that negative power. And last but not least, rational exponents, the fractional exponents, those are indicating which root you're taking of your number. If you have 1 over the n power, you've got the nth root of your number. If you've got m over n power, you've got the nth root of that number, and then it's raised to the m power. So the rules are here. Use them as you need to for as we look at the next page and look at a whole big collection of problems to help you review what rules they go. All right, so some simple reminders for you before we start these. You want to try and do them without a calculator. You want to show the steps as though you're applying the rules. Don't give decimal answers. That would mean you are using your calculator, so answers in fraction form should stay in fraction form. And your answers are considered simplified only if they do not have negative exponents in their answer. So why don't you look through the collection here, see how many you think you know how to do, work on them for a few minutes, and then we'll come back and review and go over those answers. All right, so you get to work now, see how many you can do on your own. All right, let's see how many you got right here. The first one is probably one of the more often incorrectly done problems. The calculator, when it goes on your calculator, interprets this as negative 1 times 3 to the 4th. But most people take it as the number negative 3 to the 4th power. So 3 to the 4th power is going to be 3 times 3 times 3 times 3, which is the same as 9 times 9, and this is a negative 81. All right, contrast that to what you see in number 4, and that says the number negative 3 is multiplied by itself 4 times. And that means we do get a positive product. We get a positive 81. All right. Negative powers, move it and lose it time. 5 to the negative 3 is in the numerator. It goes to the denominator. It becomes 5 to the positive 3. And then 5 times 5 times 5 is 125. So besides reviewing your rules, you probably want to review a couple of the powers of the integers as well. All right, number 6, move it and lose it in both numerator and denominator. So the 2 to the 3rd becomes positive in the numerator. 3 to the 2nd becomes a positive power in the denominator, and then we evaluate. 2 to the 3rd is 8. 3 to the squared is 9. Number 7, 0 power. Only the x's to the 0 power. So this is negative 5 times a 1 over 2, or just simply negative 5 halves. 28, now we've got a rational exponent. So the bottom number becomes your root. The top part of your power becomes the power that you raise that root to, and the negative 27 is in your radical. All right, you can take a cube root if you have 3 of the same factors. So 27 is the same as negative 3 times negative 3 times negative 3. So I can take out that negative 3 for the cube root, and then I have to square it, and I get a 9. All right, 3 halves power. This time, the index of your root is the bottom number, so it's a 2, meaning it's a square root. The top number is what power your radical is raised to, and you're doing the square root of 9 over 16, and then you're going to cube that. Okay, both 9 and 16 have a square root, so you can get 3 over 4, and then as you cube the 3 over the 4, you get 3 to the 3rd power is 27, and 4 to the 3rd is going to be 64. All right. Now, on to number 10. Make it bigger space so we can see what we're doing here. All right. We're going to go to a negative 2/3 power for that fraction, which means that the numerator, which means the numerator is going to be to the negative 2/3 power, as well as the denominator. Now we change the powers so they're positive. 125 to the positive 2/3 power in the numerator. 8 to the positive 2/3 power in the denominator. And then we can come back and work with the radicals. So we're going to do the cube root of 125, and then we're going to square it. And then we're going to do the cube root of 8, and we're going to square that. Since 125 is 5 times 5 times 5, the cube root is 5. It's going to get squared. Since 8 is 2 times 2 times 2, the cube root is going to be 2, and we're going to square that. And then the answer will be 25/4. All right, continuing on here, we've got multiplying some products of expressions here. So looking at number 11, this is the same as if I were to rearrange as though I had -6 times 7, x to the 4th, times x to the 3rd, times y to the -5. And that just kind of emphasizes that you've got the like powers multiplying here, and you're going to use the exponent rule of adding the powers. So back to finishing up the problem. The coefficients are going to multiply, -42, and now the powers are using the exponent rules where the exponents are adding. This power here is a y to the positive 1, so as they add, you have a y to the -4, and then the last thing you do is take care of that negative power so that your answer doesn't have negative powers, and you have the -42 x to the 7th over y to the 4th. Now, notice -42 didn't move. That's not an exponent. Coefficients being negative do not move to the denominator. They're not using the exponent rules. So this one is now finished. On to number 12. Again, coefficients are going to work as the fractions they are. They're going to reduce. The exponent powers, where you've got your like bases here and here, that's going to be your quotient rule, and they're going to subtract. And then we also have the negative exponent, where we're going to have to move that for a positive. So first thing, reducing the coefficients, they both divide by 5. So there'd be a -3 halves. And the quotient rule, there are more powers of a in the denominator, so when we subtract, the a squared is left in the denominator. So there's going to be an a squared there, and then finally the negative power has to move down, and it becomes b to the 3rd. So coefficients have reduced, powers have subtracted, leaving the bigger power in the denominator, and the negative powers move down. And that one is done. Number 13, you've got to watch your order of ops here. We've got the first term is raised to a power. That power has to be taken before you can multiply by the second one. So we are going to do a power of a product here. The coefficient is going to get cubed. The x to the 3rd is going to get cubed, and the y squared is going to get cubed. We're doing all of that before we multiply by that second term. So the 2 to the 3rd is 8. The power to the power, now we're using the rule where the exponents multiply. Another power to power, y to the 6th. And then we can come back and multiply by -4, x to the 4th, y squared. Now we have a problem just like number 11, where your coefficients are going to multiply, giving you -32. And then your powers, now you're multiplying like bases, so those powers are going to add. And that's going to give us x to the 13th. And finally, the powers of y are going to add, and that's going to give you y to the 8th. All right, a couple that are in fraction form here, and there is probably multiple ways to approach number 14. I like to look at the inside part, see if you can do anything inside that parenthesis before you try to do the powers, and you can do some moving of your negative powers. So I'm going to leave that power on the outside as it is right now, and simply take care of the powers that are in the inside. So the x to the third goes to the bottom. The x to the squared goes to the top. The y is negative. That goes to the bottom. But the y that's down there is positive, and that stays there as it is. All right. Now we can still do some simplifying before we try to take care of that negative power. All right. The x to the second over the x to the third can use the quotient rule. So we should be able to have an x to the first in the denominator. And that would leave a 1 up in the numerator. And then we also have multiplying like bases here, and that would be y to the fifth. Now if you want to raise everything to the negative 2 power, you're going to have the 1 to the negative 2. When you raise x to the first to the negative 2 power, powers would multiply. Y to the fifth to the negative 2 power, the powers would multiply. And then you can come back and you can, oops, fix that guy up. And then, okay, and then we can finish this guy up by just putting the denominator values up to the numerator so they're positive, and the 1 goes to the bottom. So the answer would be x squared, y to the 10th over 1. Number 15 looks nice and short, and it is. You're just going to be working with multiplying your coefficients here. And you're multiplying powers. Let's make this guy a little bit bigger, see those fractions better. And you're multiplying powers with the same base, which means that your exponents have to add. So coefficient of negative 24, and adding the fractions, common denominator 12, this would be 4/12, and the other fraction would change to 3/12. Now you can add the powers, negative 24, x to the 7/12. All right, finishing up here, we've got a quotient and got some coefficients that are going to reduce, and we've got quotient property with our powers where they're going to subtract. So starting out here, we're going to make our fraction bar. We're going to divide 4 from the top and the bottom, be left with 3/4. Now looking at the powers of x, the power on the bottom is a bigger power than the power on the top. So I'm going to subtract those powers in the bottom, x to the 3/4, subtract the 1/6. And then looking at the powers of y, the power in the top has a bigger fraction than the power on the bottom, so those y's are going to subtract in the numerator. Y to the 1/2 is going to subtract 1/4. All right, get some common denominators. Then we have a common denominator in the top of 4ths. So we have y to the 2/4 minus 1/4. And in the bottom, for the x's, the common denominator is 12. So x to the 9/12 minus 2/12. And finishing up, we're going to have 3 y to the 1/4 over x to the 7/12. And that one is done. So check things over, see how many you got right. Head to your day 2 on your assignment sheet. Check back at your exponent rules and the examples, and don't forget to check your answers in the back of the book and see how you're going. Show your steps and be sure you're simplifying with only positive exponents in your answer. Good luck.